present here. Today, we are going to learn about electronic lock using basic logic gates, which comes under the digital application, which we are going to stimulate through the virtual lab. Now, let me tell you the process to get into the virtual lab. Go to Chrome, search virtual lab, and click on to virtual lab. Just scroll down, you'll find electronics and communication. Just click onto it and you'll get these many domains in which you have to choose digital applications lab, and again you have to choose the list of experiments, and you'll find about 1 to 14 experiments. Today we are going to learn about electronic lock using basic logic gates. So open it. You'll find aim, theory, procedure, everything. First, I'm going to teach you the aim, theory, procedure, and the stimulation of this experiment. And after this, you're going to take a pre and post test for any references. You can go through this. Initially, we'll look into the aim of this experiment. To study the application of a combinational electronic lock using basic logic gates, the user will be able to design a 4-digit electronic code using 2 input basic logic gates. Using the generalized stimulator, the user can implement his design and verify its work. Secondly, we'll move to the theory, and you'll find introduction, concept, and the steps, and finally the truth table, and we'll look one by one. Firstly, introduction. A typical travel suitcase or bag is provided with a 3-digit or 4-digit security code lock that unlocks for only predefined combination of these digits. An electronic lock is a digital combinational circuit that is analogous to the travel suitcase lock code. And secondly, an electronic lock opens, output goes high only for certain combinations of the digital inputs. For 3-digit code lock, there will be a 2 power 3, that is 8 combinations, whereas for a 4-digit, there will be a 2 power 4, that is 16 combinations of input. In this experiment, the design steps for a 4-digit electronic lock that operates for 2 code combinations are explained. Based on the user's need, an electronic code lock can be designed so as to operate with multiple combinations of input using basic logic gates. Moreover, the lock can be made more secure by increasing the number of digits. Secondly, we look into the concept of electronic locks using basic logic gates. The electronic clock is designed with 4 inputs A, B, C, and D. A high output will open the lock and the LED turns on. Let us consider that the 2 combinations of input switches, that is 0001 to 1011, which we have taken in the binary format. And secondly, generate one high as the output and opens the lock. Finally, we look into the design steps which is involved in this experiment. The first step is to prepare a truth table with A, B, C, and D for 4 inputs, resulting in the 16 possible combinational outputs. So second step is to convert the truth table information into a Boolean expression. Boolean expression is nothing but converting the terms into binary format. Form a min-term Boolean expression for electronic lock circuits, and here they have given the truth table. I hope you all know about this, so just go through this truth table, and from the truth table only 2 of the 16 possible combinations of inputs, that is A, B, C, D, generate a logical input of 1. The 2 combinations that opens or the lock are, that is A bar, B bar, C bar dot D, and A bar dot B bar dot C, D, where bar represents the complement of A, B, C, or D, anything else. And the next step is, when these 2 combinations are read together, the resultant Boolean expression for this application min terms Boolean expression for the electronic clock is given by y is equal to A bar, B bar, C bar, D plus A, B bar, C, D. As I've already told you, bar is nothing but the complement of the same digit or the values itself. With the views of use to use the 2 input gates, the expression can also be rearranged as y is equal to b bar dot d and a dot c plus a dot c bar. And finally, they have given a conversion of Boolean expression logic diagram. If you have any doubts, just go through this diagram. You will understand everything. And the final thing is to observe what combinations of input and the output goes high and the lock opens, thus which gives a validated design. Uh, till now we have seen about the theory, and next you look into the procedure of this experiment. You just have to click on the input switches to find what is the output of the experiment. And they have also given a YouTube link. If you have any doubts, you can go through this link and get cleared. Finally, we look into the stimulation part. Okay, they have already given the circuit, and there are four inputs, that is A, B, C and D. These three are the digital switches which are the four inputs, and this is the LED light, green LED light, which is the output. And they have used um, about four AND gates, one OR gate, three NOT gate and two Y connector, and they've connected with the wires. If you click on to this, I'm just clicking all of the four switches and I don't get output. So now change to 3, I don't get any output. So now again change 3. Okay, now I've turned off this B alone, but I got the output as a green LED light. So by changing the inputs, you'll get the output. There are 4 inputs and 1 output. I hope you understood this. If you have any doubts, you can go through the references and get clear. You can also stimulate this. Thank you for watching this video.